You know that the space is quite dark and there are no signs of life in it. Sun is the only source of light in our galaxy. But now we have seen a strange glow in the center of our galaxy and it is not what we thought it was. Then what it is actually? Well, stay tuned to Gateway to Knowledge to answer this fascinating question. The center of the Milky Way is glowing. Yes, there is a big chonkin black hole and it is very energetic region. But there is an additional high energy gamma ray glow above and below the activity, and it is something that is yet to be explained. This glow is called the Galactic Center GeV Excess GCE, and astronomers have been trying to figure it out for years. One of the most current debate on this explains that the glow might be theoretically produced by the annihilation of dark matter, but new research is a nail in the idea's coffin. In a series of efforts that include recent developments in stimulating the galactic bulge and other sources of gamma ray emission in the galactic center, a team of astrophysicists have ruled out dark matter annihilation as the source of the glow. In this finding, the team gives dark matter less room to hide, placing stronger constraints on its properties that could aid in future researches. The GCE was first noticed a little over a decade ago, when the Fermi Gamma Ray Space Telescope started surveying in the region. Gamma rays are the highest energy electromagnetic waves in the universe, and they are produced by the most intense objects such as millisecond pulsars, neutron stars, colliding neutron stars, black holes, and the supernova. The problem was when it came time to analyze Fermi's observation, after all non-gamma ray sources were subtracted, we ended up with an gamma ray glow in the heart of the Milky Way that couldn't be accounted for. In space, when you find something that cannot be accounted for, it makes sense to try to match it up with other things that cannot be accounted for, like the dark matter. This is the name we give to the invisible mass that adds gravity to the universe. We can detect dark matter indirectly because things move differently from how they should if only the visible stuff was having, but we don't know what it actually is. However, while we can't detect dark matter directly, it is possible that it produces radiation that we can see. If the types of dark matter particles called the weakly interacting massive particles or the WIMPs were to collide with each other, they would annihilate each other, exploding in a shower of other particles, including gamma ray photons. Such collisions have been put forward as a potential mechanism producing the GCE. Several studies, however, have found no evidence of WIMP collision, but this new study is a step up. Over 3 years, the team pulled together a wide range of gamma ray modeling scenarios for the galactic center and its bulge. They included all the sources they could get their hands on: star formation, the Fermi bubbles, cosmic ray interactions with molecular gas, and neutron stars. They found that once they had factored everything in, there was very little room left behind for the WIMP annihilation. Between all these gamma ray sources, there is no significant excess in the galactic center that may be attributed to the dark matter annihilation. However, the previous research have found that the distribution of gamma rays in the galactic center is also inconsistent with the dark matter annihilation. If weakly interacting massive particles were the culprit, the distribution would be smooth, but instead the gamma rays photons are distributed in clumps as you would expect to find from point sources like stars. The distribution of stars in the bulge, according to the new research, is also inconsistent with the presence of additional dark matter. That's not to say the dark matter in our galactic center could not be of some hypothetical massive weakly interactive type. The team has found that their findings still strongly favor an astrophysical origin for the GCE, and our study constrains the kind of particle that dark matter could be. The multiple line of evidence for dark matter in the galaxy are robust and unaffected by our work, which means we are just going to have to think a lot further outside the box to find it. So that's all from my side. If you enjoyed my today's video, then do like and subscribe to my channel. But if you are a book reader and you want to read some amazing books, or you want to purchase something from an online store, then below in the description is the link of my Amazon account. Go and check it out.